Hi, welcome to Raji's class. This video will helpful to the chemistry person, those who are prepared for CSR NET, then TRB Polytechnic exams and PGTRB also, and also used for school students, those who are get ready for JEE as well as NEET exams. In today's topic is nuclear chemistry. Nuclear chemistry is the branch of chemistry deals about the study of nucleus. The study of nucleus of an atom is important. Why means nucleus is considered as the source of tremendous amount of energy, and that energy can be used for destructive as well as constructive purpose. According to Rutherford's experiment, nucleus is the small particle and its size is so small when compared to the size of the atom, and the radius of the nucleus is 10 to the power minus 15 meter, but the mass of the nucleus is more when compared to the mass of the atom. That means the mass of the atom is concentrated in the nucleus, and the density of the nucleus is also higher, and the density of the nucleus is generally 10 to the power 12 times higher than the densities of lead. Although more than 20 different particles have been detected as the products of different number of reactions, different nuclear reactions, the particles neutron and proton is called as building blocks of nucleus, and these are collectively called as nucleons. Nucleus is very small, and two protons lying in the nucleus are found to repel each other. Then how would be it possible to arrange a large number of protons in a tiny space without repulsion? It is postulated that a strong proton neutron 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 and even proton proton attractive force is existed between the nucleus, and that attractive force is considered or called as nuclear force, and it is the short range force, and this force is 10 to the power 21 times stronger than the force of electrostatic force, and it is the long range force used to combine ions, and that force form stable solids. Then the application of nuclear energy. The energy obtained from nucleus is used for several purposes. That energy can be used as nuclear power, nuclear weapons, then also used in the department of archaeology. Then some conditions, the energy obtained from nucleus is used as nuclear medicine, and the radioactive materials are used for the treatment of cancer, and it also used as cosmochemistry. Cosmochemistry is nothing but it is the study about chemical composition and the changes in the universe. Next, nuclear stability. Nuclear stability is nothing but it explains about the stability of the isotopes. Generally, the nuclear stability is based on two factors. One is based on the number of protons or neutrons present in the nuclei as well as NP ratio. Whenever the nuclei containing the magic number of protons or neutrons, they are considered as more stable than the nuclei containing non-magic number of protons, and the NP ratio is also used to explain the stability of the nucleus. When this ratio is equivalent or greater than 1.5 means at that condition the stability is lesser. That means when the atomic number of the nucleus is 84, the atomic number of the isotope is equivalent to 84 or higher means the elements are unstable, and they are called as radioactive elements. When number of protons and neutrons are considered as more stable than nuclear width, whether even with add number of protons or add an even number of protons and neutrons or add number of neutrons and protons, can be explained with the concept of mass defect. Mass defect is nothing but it is the difference between expected mass and the actual mass. Generally, the observed atomic mass of isotopes is lesser than the sum of the weights of protons, neutrons, and electrons. So, this difference is called as mass defect. For example, let us take the example of helium. The expected mass of helium is equivalent to the sum of the masses of the protons, neutrons, and electrons, and it's equivalent to 4.034 atomic mass units. Then the actual mass of helium is 4.003 atomic mass units. It is nothing but after forming helium, the actual mass is equivalent to 4.003 atomic mass units. So the difference between these two mass, that means expected mass and actual mass, is called as mass defect. So whenever an isotope is formed, means this mass defect is converted into energy, and that energy is called as binding energy. Binding energy is nothing but the energy which is used to combine the neutrons, protons, and electrons in the isotope is called as binding energy, and it also represents the energy when the molecules is broken into individual parts. And this energy can be explained with Einstein equation. Einstein equation is E is equal to mc squared. The m can be replaced by mass defects and c denoted as the velocity of light, and the term also replaced by mass. The mass can be explained in different units. For calculate the mass defect, the mass value can be used as 931.5 million electron volt. For example, by using the above equation, we can calculate the binding energy of helium. That energy is equivalent to mass del m into 931.5 million electron volt. So whenever we substitute the mass defect value of helium, and it gives the binding energy of helium, and that is equivalent to 28.8 million electron volt. Generally, the binding energy per nucleus is a measure of the stability of the nucleus. So whenever the binding energy is higher, means the stability is also higher. And binding energy is related with the term mass defect. So these all the terms are related with each other directly. So whenever mass defect value is increased, means binding energy is increased. So this binding energy indicates the stability of the nucleus. Nucleus is 8 million electron volt, means generally the nucleus are considered as more stable. For example, the binding energy of iron is 8.79 million electron volt. So iron is thermodynamically more stable. Then the isotopes with mass number of between 40 to 100 are more stable. Low mass numbers or high mass numbers tend to become stable by acquiring intermediate mass number, and this intermediate mass number can be occurred by two processes. One is called as nuclear fusion, another one is nuclear fission. That means the lighter elements combined together and to form heavier nucleus means that is called as nuclear fusion. And when the heavy element splits into lighter elements and form intermediate mass number means that process is called as nuclear fission. So through these two processes also the isotopes can attain the stability. Packing fraction is defined as the difference of actual isotopic mass and the mass number. That means packing fraction is equivalent to actual isotopic mass minus mass number divided by mass number into 10 to the power 4. The actual value of isotopic mass is the fractional number and the mass number is the whole number. So this packing fraction value may be positive or negative, or sometimes the value is equivalent to 0. For example, whenever the actual isotopic mass is equivalent to the mass number of that isotopes means at that condition the value of packing fraction is equivalent to 0. For example, carbon 12, it is considered as the reference isotope to calculate the atomic mass unit of other isotopes. So the packing fraction of carbon 12 is 0. Next, the value may be negative. So whenever the actual isotopic mass is lesser than the mass number of that isotopes means at that condition the packing fraction value is negative, and third isotopes are considered as most stable one. Then actual isotopic mass is greater than mass number means the packing fraction value will be positive, and third indicates that isotopes are unstable. The packing fraction value can be related with binding energy and stability. So whenever the packing fraction value is lower means at that condition the binding energy will be higher and the stability of the nucleus, that means isotopes also higher. We'll see about the problems related to mass defect and packing fractions. Thank you for watching.